Friends, in this session we are going to see how a mathematical concept makes things easy, less time consuming and accurate. Here you can see a road, and on both the sides of the road there are street lights. So using this situation, let's see what we come up with. Consider there are two poles on both the sides of this road. And let's draw two triangles by joining these poles. So by looking at the diagram, can you tell me what is common between these two triangles? They have a common base, right? One more thing is common between them. Height. Height is also common because if we see the boundary of the road, they form parallel lines. And we know that the distance between two parallel lines is always constant. Therefore, height and base is same for these triangles. So when we calculate area, we use the formula half into base into height. Since height and base are equal for both the triangles, so its area will also be equal. Now, what does this imply? It implies when two triangles are drawn between two parallel lines with same base, then their areas are equal. Let's try some other combination of triangles and see what we learn through this example. Now consider a single light pole on one side and three light poles on the other side. Again we draw two triangles. So now can you tell me what is common between them in terms of base and height? Yes, height will be common. And what about base? Here base are different for both the triangles. If we notice a diagram, we can easily make out that we have split a triangle into two by joining a line. Here we don't even need two parallel lines to show that these triangles have equal height. So the conclusion is, if we draw two triangles by splitting a triangle, then height of all the triangles will be equal. And when we find the area of these triangles, area will not be equal, but ratio of their areas will be equal to ratio of their bases. Because when we take the ratio of areas, the constant value 1/2 and the height will get cancelled, and the remaining thing will be the ratio of the bases. Friends, in this session we are going to use these properties of triangle and introduce a new property of a triangle. So without taking too much of time, let's see what we are going to derive. We are going to prove that if a line is drawn parallel to one of the sides of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Friends, we can prove this statement by using two properties which we discussed earlier in just 3 simple steps. So we'll start with our first step. If we see the left part, it involves two sides AD and side BD. So first of all, we will take two triangles involving these sides. The triangle ADE has side AD, and we will join line BE to get triangle BDE, so that this will become a triangle with sides BD. We know that area of any triangle is calculated as half into base into height. Since AD and DB are required for the proof, so let's take them as base for respective triangles, and we will find ratio of their areas because we want the ratio of AD and BD. We can see that these two triangles are made in a large triangle ABE. So by using our second property, we can say that height for both the triangles are same. So ratio of areas can be written as area of triangle ADE upon area of triangle BDE is equal to AD upon BD. By cancelling out the constant value half and equal height. So this is our first step. It was very simple, right? Now we'll go to the second step. Now here we see that there are again two sides, AE and EC. So similarly, by joining line segment DC and following same steps for triangles ADE and triangle CDE, we can write ratio of their areas as area of triangle ADE upon area of triangle CDE is equal to AE upon EC. Again, by cancelling the constant value half and the equal heights. This step was quite similar to the first step. Let's mark it as equation number 1 and equation number 2. Now, the third and final step. As we can see that in both the equations we got AD upon BD and AE upon EC. But we have to show that these two equations are equal. Only then we can say that the ratios are equal. So, if we see the left hand side of the equation number 1, it is ADE upon BDE, whereas left hand side of the equation number 2 is ADE upon CDE. So if we have to show the right hand side of these equations equal, for that left hand part should also be equal. On the left side we have a common triangle ADE. Now if we can prove the areas of triangles BDE and CDE to be equal, then left side of both the equations will become equal. So right hand side will also be equal. Means ratio will be equal and we are done with the proof, right? So guys, let's focus on the triangle BDE and triangle CDE. Now by looking at the diagram and applying some logic, we will be able to figure out that these two triangles have equal areas by using our first property of the triangle. We can see that for triangle BDE, if we consider DE as base, and for triangle CDE, again let's consider base as DE only. So DE is base for both the triangles, and these triangles are drawn in two parallel lines. Those lines are DE and BC. That means height of these two triangles are equal, which implies areas will also be equal. That means area of triangle BDE is equal to area of triangle CDE. If areas of these two triangles are equal, means left hand side of the equation number 1 and the equation number 2 are also equal, right? This was our third step. So from equation number 1, 2 and 3, we can say that ratio AD upon DB is equal to AE upon EC. And the third property which we learn in this session is, if a line is drawn parallel to one of the sides of a triangle to intersect the other two sides in distinct point, then other two sides are divided in the same ratio. This statement is called as basic proportionality theorem. So here we end up with the session. If you like the video, then please hit like. Do subscribe to our channel. Thank you for watching. Keep watching, keep learning.